Algebraic expressions. You guys are going to like this section because it's just identifying terms and coefficients and what it means to be an algebraic expression, simplifying by combining like terms, and then evaluating. So you're going to substitute values in. So you'll find that this is very much Algebra 1 rooted. So let's just start off with some vocab. An algebraic expression has three parts. Okay, it's got to have letters, which we call variables. And then it's got to have numbers, which we call constants. And then we have add, subtract, multiply, or dividing between those constants and or variables, which we call operations. So for example, x squared minus 3x plus 6. This is an algebraic expression because it has letters, it has numbers, and it has operations like subtract, add, and even an exponent raised to a power is an operation. It also has multiplication between the 3 and the x. Okay, so terms are those parts of an algebraic expression, and they're separated by addition. And remember that addition is also a way of, or subtraction is also a way of addition, so I'm going to put subtraction here too. So terms are parts of an algebraic expression that are separated by addition or subtraction. So in this example that I've given you, let's pick out the terms. So actually, let's use a different example. Let's use the same one. X squared minus 3x plus 6. The terms here, let's just list the terms. The terms here are those things that are separated by the subtraction or addition. So I have 1, 2, 3 terms. I have x squared, I have 3x, and then I have 6. Now we're going to classify these different terms, again there's 3 of them, into 2 categories, variable terms or constant terms. A variable term is any term that has a variable in it or a letter. A constant term is a term that doesn't have a variable. Okay, that's pretty self-explanatory. So let's pick out between these 3 which are the variable terms. Okay, x squared has a letter, and then 3x has a letter. But 6 doesn't, so we call that a constant term. It's the term without a letter. Another definition is a numerical factor of a term. That's the coefficient. The coefficient is a number. It's only a number, and it's being multiplied by the letter. Okay, so it's a number that's multiplied by a letter. So let's pick out the coefficients. In other words, the numbers that are in front of the letter. Okay, so we're going to find our letters. We have 2 of them. What's the number in front of x squared? Oh, it's an invisible 1, right? What's the number in front of 3x? Oh, it's a 3. So the coefficients are just the numbers that are in front of the letters. Right here I've given you 4 algebraic expressions. We're going to pick out the terms, and then we're going to pick out the coefficients. So let's start with the terms. Remember, terms are separated by addition or subtraction. So if I draw a line here where the addition is, I have 2 terms. I have a 10x and I have a 5. Now if I pick out the coefficient, remember coefficients are the numbers that are with the letters. So looking at my terms, I see 1 letter and the number with it is 10. Okay, down here, how many terms do I have in this one? Well, there's a subtraction sign, so terms are separated by subtraction. So let's list the 12 and the negative 6x squared. Notice how I circled the sign in front. On the last one, the sign in front of 5 was positive, so I just wrote positive 5. But I could have circled it if I wanted. I just don't have to write a plus 5 there. So positive 12 and a negative 6x squared are my terms. Let's find the coefficient. Coefficient is the number in front of the x. So I only have 1 again. It's a 6, negative 6. Down here I have 3 terms. And I always circle the sign that's in front of the term because it goes with it. So I list out my terms. I put a comma in between. to show that it's a list of items. And coefficients, so again, I see 2 letters, so I'm going to list the 2 numbers that are in front. So -3 is a coefficient, and 2. Notice how the coefficients don't get any letters. Okay, it's only the numbers. And I want you to pause the video and go ahead and list the terms for the last one and the coefficients for the last one. All right, I want you to check your answer with mine here in the notes. The terms, there's 4 of them. Make sure that you put the negative with the B. Everything else is positive. And then the coefficients, there are 3 of them since I had 3 letters. It doesn't matter the letters, right, as long as it's a number in front. So I had a 7, a 4, and remember there's a hidden -1 here. So -1 was a coefficient. If you have questions, please raise your hand and let me know. Okay, now simplifying these algebraic expressions. One way to simplify is to combine like terms. Like terms are terms that have the same variables and they have to be raised to the same exponent, those variables. So let's start by listing some examples because it can get kind of complicated. Obviously, we know that 2x and 3x are like terms. Okay, but what happens if I have something like 2x squared y as a term, and I have -x squared y? So we need to check, do they have the same variables? Yeah, this one has an x, and this is an x. This one has a y and a y. So they have the same variables, but check if those variables are raised to the same exponent. So the x has to be squared. Okay, it's squared in both. And the y has to be raised to this imaginary first power, which we don't need to write. So yes, same variables raised to the same power. It does not matter what the coefficient is. For instance, this is a 2 and this is a -1. As long as the same variables raised to the same exponent. Something that you may not find as like terms is items like 3 and -5. Those are like terms because they have the same variable, which is nothing, and that variable is raised to the same exponent, which is nothing. So we can combine them. Let's see. Oh, another common mistake is if I have, let's think, I don't know, 5x y squared and 6y squared x. So let's look. Do they have the same variables? This has an x and this has an x. This has a y and this has a y. So same variables, nothing extra. And are those variables raised to the same power? Yeah, the x is to the first and the y is to the second. So the only thing that's different is the order has switched, which is okay because it's multiplication. That's fine. So it doesn't matter the order as long as same variables, same exponents. Okay, let's list some non-examples because it helps to see sometimes what's not a like term. Sticking with that same theme, let's show you this one that's a non-example. And why would this not be like terms? Because I see that they have same variable, x and x, y and y. And there's a power 1 and a power 2 and a power 1 and a power 2. So why are these not like terms? Well, look at where the exponent is. So the x in this one is raised to the first, and the x in this one is raised to the second. That's not okay because those variables aren't raised to the same power. So that would be a non-example. Another non-example would be 3b and 3a. Yes, they have the same coefficient, but look at their letters, a B and an A. I cannot combine those. Can't combine bananas with apples. You probably heard your 8th grade teacher say that. So just check. If they have the same variable and the same power, then they are like terms and we can combine them. When I mean combine, I mean add or subtract is what I mean by combine. Okay, so let's practice combining like terms. I teach this by either circling or boxing in the like terms. So let's, for instance, circle everything that doesn't have a variable because those are like terms. So -3 and +5. Again, I'm circling the sign in front. I see a 2y here, so I want to check and see if 7y has the same letter and same power. So I'm going to box those in. Those are different terms, but they're the same. So I want to combine my circles, and then I want to combine my squares. So -3 plus 5 would give me a 2. And then I have a 2y minus a 7y, or a 2y and a -7y. Shoved together, that makes -5y. Notice, I only deal with the coefficient part. It's not y squared or 2y. The y stays the same, and I just combine the front numbers, right? It's 2 yo-yos, take away 7 yo-yos. How many yo-yos do you have? -5. So I can write it as 2 minus 5y, or I could put it as 2 plus a -5y. Either one means the same thing. Okay, down here, let's try to figure out, actually, I'm going to skip down to this one, and then I'm going to let you do the middle one on your own. So down to the bottom one, because it looks a little harder, we want to do it together. I always start by circling the first one. I'm looking for terms that have an x to the first and a y to the second. So jump over here. No, that has an x squared. Oh, this is x to the first, y to the second. I'm going to give it a circle just like I did the first one. And then this one, nope, it has an x squared. So then I go back and I box in the next term. This next term has an x squared and a y squared. So I'm trying to see, oh, x squared, y squared, box it in. And I just keep going down the line until everything has a circle, square, triangle, pentagon, hexagon, however many shapes you need to use. And then I combine. So let's combine circles. I have a 3 and a 2, and they're both positive, so that's 5. And then I keep the terms the same. It's x to the first, y to the second. Okay, now I'm going to combine rectangles. I have a -4 and a positive. Remember, this is an invisible 1. So -4 plus 1 would be -3. And I keep the variables the same and the powers the same, and it's x squared and y squared. And that's all the further I can go. It's my final answer. I can't combine those anymore. Do not subtract 3 from 5 because those aren't like terms. I can't combine them. Okay, so pause the video. Go ahead and try the middle one. Okay, you should have got -3x squared plus 2x, or you could have written it as 2x minus 3x squared. I think WebAssign will take either. Hopefully. If it doesn't, call me over and I'll help you out. But I did circles and squares again because I want to combine my circles and then combine my squares. So x squared and x squared got circles. So 2 minus 5 was -3. And then x to the first got rectangles. So 3 minus the imaginary 1 here. And I got a +2. Questions? Call me over and I'll help you out. Removing grouping symbols. So this is one that we're going to have to, it's a skill that we're going to have to use all throughout. Let's just look at the first one. It says 3 times the quantity x minus 5 minus the quantity 2x minus 7. Okay, so first of all, we want to use our distributive property and multiply this 3 into our first set of parentheses. So when I do that, let's work our way down. We get 3 times x, and then I drop down my minus sign, and 3 times 5 was 15. Okay, I'm going to keep everything else the same so far. So all we've done is distribute. Notice how it says minus all of this in parentheses. So it's not just subtracting the 2x, it's also subtracting this -7. So what I'm going to do is technically distribute this negative sign. You can think of it as a -1 out in front. Just like we distributed the 3, we're going to distribute a -1. So what happens when I distribute a negative, I'm flipping the sign of the terms inside the parentheses. So let's drop down our 3x minus 15. This was a +2x. If I take it times a -1, I get a -2x. And if I take a -1 times a -7 in here, I'm getting a +7. So I've removed all of my parentheses. I've removed the grouping symbols. This step right here, distributing a negative, students go wrong all the time. What they do is, okay, so they had the 3x minus 15 correctly, but they'll just write minus 2x minus 7. They distribute it to the first one. They subtracted the 2x, but they forgot to subtract the minus 7. So notice the difference here. This is a plus 7 and this is a minus 7. You're going to get a completely different answer, and it's going to be wrong. Okay, so that's a non-example. Distribute it to both terms, just like you distributed the 3, the x, and the negative 5. So now that we have removed our grouping symbols, we can combine like terms. So I have a 3x and a minus 2x, a negative 15, and a positive 7. The 3 take away 2 is 1x. You can write the 1 or you don't have to. Negative 15 plus 7 is negative 8. So my final answer is x minus 8. Down here in the middle one, looks a little tricky because I have parentheses and brackets. Let me change colors. I'll use purple. Okay. So let's start with the innermost, the parentheses. So I'm going to drop down everything that I haven't used. And I want to distribute my 2 to both the x and the negative 7. So I get 2x minus 14. Okay, I got rid of my parentheses. Now I just have brackets. We can combine the like terms in the brackets if you want. We can do that first. So if I circle the 3 and the negative 14, I combine that. Let's go ahead and do that, actually. So combine like terms in the brackets, if I can. I couldn't combine like terms in the parentheses in the step before because it was an x and a 7. Those aren't like terms. So drop down everything else. My 2x and 3 take away 14 would give me negative 11. Okay, so I can't combine anymore in my brackets, a 2x minus 11. Those aren't like terms. But this negative 2x here, since it's hugging this bracket, just like this 2 was hugging the parentheses, it means I need to distribute. So we're not distributing the x, we're not distributing the negative 2, we're distributing all of it. And distribution means multiply to everything in the parentheses. Okay, so drop down the 5x. Negative 2x times a 2x. Okay, so let's start by multiplying the coefficients. Negative 2 times a positive 2 would be a negative 4. And I have an x times an x. How do I write that? Well, we learned earlier that if you took 7 times 7, you can write that as 7 squared. So x times x would be x squared. That's a little sidebar over here. So x times x, tack an x squared on there. And then I have my negative 2x times my negative 11. Don't forget the negative in front of it. So I can multiply things that aren't like terms. So even though this has an x and this doesn't, I'm still going to multiply it. Okay, combining like terms talks about adding and subtracting, not multiplying and dividing. So I get a negative 2 times a negative 11, that's positive 22. And an x times no other x means I just have one x there. Okay, so once I got rid of my brackets, now again I'm going to combine like terms, if I can. I have a 5x, and I go, oh, that's an x squared. Oh, here's a 22x. So circle them. This one gets his own box. There's no other boxes, so I can't combine him with anything. But let's add our 22 and our 5x to get 27x. And then I have a negative 4x squared. Remember, again, you could also write it in this order, negative 4x squared plus 27. Either one would work. Okay, the last one. If you feel confident, you can pause the video. If you don't feel confident, we can walk through it together. So I have one grouping symbol here, and it's 5x to the 4th, and it's being multiplied by negative 3x. So I'm going to multiply those. Remember, we multiply coefficients, so negative 3 times 5 would be negative 15. And if I'm multiplying an x times x to the fourth, well, x to the fourth means x times x times x times x. How many x's are being multiplied? 1, 2, 3, 4, 5. That's x to the fifth. And then I have a plus 2x to the fifth off to the side after I do the distribution. If I have like terms and combine them, I have x to the fifth, and I wrote squared, but it's x to the fifth. And I have an x to the fifth there. So negative 15 plus 2 would be negative 13 x to the fifth. Remember, don't add the exponents here. It's not x to the 10th. It's just saying I have 15 xylophone plus 2 xylophones. Okay, it doesn't matter the fifth power. The power only matters when you are multiplying, not combining. Again, questions, please ask. Okay, last one is evaluating. Evaluate the expression 5 minus x. So this is our expression. 4x equals negative 2. So it's telling you to substitute. It's like in football or volleyball or basketball, baseball, soccer, whatever it is. It's saying, hey, this person X, he's been in the game long enough. We need a sub for him. Who's going in for X? Oh, negative 2. So when a sub in a game happens, you have to take that X out. So 5 gets to stay in the game. Minus gets to stay in the game. Squared gets to stay in the game. But X, he's got to come out. And we have to put negative 2 in his place. Both of them can't be in the game at the same time. X comes out, negative 2 goes in. I'm evaluating it, so I need to come down to a final answer. So I follow order of operations, and I square the negative 2. Remember, that means negative 2 times negative 2, so my answer would be a positive 4. And it's 5 minus 4, so my answer here would be 1. Evaluate the expression when x is 2 and y is negative 1. So I have two different variables to substitute in for now. So I follow the same thing. Absolute value, y minus x. Y is coming out of the game. Who goes in its place? Negative 1. Put my minus sign. And x goes out of the game and I put in a 2. So I have to do the grouping. In the absolute value, negative 1 minus 2 would be negative 3. Absolute value means how far away from 0 is it? Negative 3 is 3 units away from 0. So don't forget, when you're evaluating, to follow order of operations. Okay, and this part B, same thing. Let's substitute in. We're still doing 2 for x and negative 1 for y. When I substitute in, I typically put parentheses if it has to do with multiplication or raised to a power. So when I put 2 in x's place, I'm going to put parentheses, and I'm squaring the x, so I'm going to square the 2. Put the minus sign, the 2. It's being times by x and times by y, so I'm going to write the times symbol. When I plug it in, it is not 2 to negative 1. That's not a number. We need to multiply 2 times the x times the y. And you can put parentheses around them if you want. It means the same thing. And then plus y squared. Y is now negative 1. So I'm going to square negative 1. And I'm going to put him in parentheses. Order of operations, folks. Let's do our exponents first. 2 squared is 4. Negative 1 squared means negative 1 times negative 1. So that'd be a positive 1. Then I can do these multiplication. 2 times 2 is 4, times negative 1 would be negative 4. So now I'm going to add and subtract from left to right. 4 minus a negative 4. Remember, minus a negative, I had that little saying where it's plus a positive. So I get 4 plus 4, which is 8. 8 plus 1, my final answer here is 9. If you tried this one out on your own and you didn't get 9, then we're having an issue with order of operations. We need to get that straightened out as soon as possible. Pause the video, go ahead and try the last one. Now x is -4 and y is -3. Okay, you should have gotten -8. So when you plug it into the top, you get 2 times -4 times -3. So multiply the top and you get -8 times -3, so positive 24. And in the bottom, you end up with -4 plus 1, which is -3. Divide 24 by -3 and you get -8. Again, if you're having trouble, please, please, please let me know. And always remember that you are important.